I hope you're doing well. This is just a video to just show you how this task number 3 is done, or part 3 of your first assignment, which is to do with this circuit. And all it's asking is to find the equivalent Thevenin circuit of this network, and then draw the equivalent Thevenin circuit for this, and also find the value of the resistance of the load, how much it should be to get the maximum power transfer to that load. And then finally, by varying the value of the load resistance, prove that the maximum power is actually occurred at that value. So to begin with, we need to look at this circuit and find basically two values to draw the Thevenin equivalent circuit. Thevenin equivalent circuit, as we said, is a theorem that basically says any network like this or anything else can be equal to a circuit that has a voltage of open circuit, which we call VOC, and an internal resistance RI in series. And all that is the equivalent of the circuit of any network. So we need to find RI from the output point of view. From this point of view, looking at the circuit, we have to find RI. So we need to eliminate battery. We need to take that out, put a wire there, or short circuit that space, and then find the overall resistance from this point of view, and we call it RI. And then we put the battery back there, and we find the voltage across these 2 points, and we call it voltage of the open circuit. And that's all you need to draw the Thevenin equivalent circuit. So if I just, we've gone through this in the class, and I've done it without any values, just using formulas. But I want to now pick a value from the list of values that you have at the beginning of your assignment. So I'm just going to go with number 5. For R1 you have 220, R2 you have 1000 ohm, and R3 8200 ohms. And R4 and 5 is given in the question, 400 and 500 ohms. And of course the voltage is 120 volts as is given. So if I just go to redraw that circuit on multisim, you'll have something like this. You don't have to draw it on multisim if you don't have multisim. There is an online version of multisim you can find online and do that. Or if you want, you just draw it on any software that you have. If you want to use Word document and use insert shapes, go on the insert, go on the shapes, and you find all sorts of shapes that you can draw, squares for resistors, or rectangles for resistors, and lines and all sorts of things, arrows for currents and all that. Or you can just use paint. However, if we just go by this circuit, this is the circuit that's given. Now we want to find the resistance of the internal resistance of the circuit. So I'll remove the battery, and my circuit will turn into basically these two resistors will be in series, and both of them will be in parallel with this. So I can just say, substitute these two as RT1, which is what I would suggest you to do. Say RT1 is R1 plus R4, which forms 400 plus 220, and that's 620 RT1 in parallel with 8200. That will be product over sum of those two. So 620 times 8200 over 620 plus 8200. And then you'll have RT2 here, or overall resistance of these three. Instead of these three, you have RT2. And then RT2 will be in series with R2 and R5. You add them all together, it'll be Ri. Here, I've just done them all together in one go. So R2 plus R5, because they're in series, if I just make it a little bit, shrink it smaller, so you can see everything together. R2 and R5 in series, it'll be added together with RT2, which I've done here in one go. But I would suggest that you do that one at a time, one bit at a time. So R1 plus R4, which is the RT1, like I said, and is repeated here, R1 plus R4. And so that would be RT1. The product over sum of that with R3, which is this R1 plus R4 in brackets times R3 over R1 plus R4 plus R3. So that is RT2 basically, plus R2 plus R5, that's Ri. If you put the values there, you'll find Ri is 2076.417 ohm for this example. Then we need to put the battery back in the circuit, redraw the circuit, which is back to this circuit again, and find out how much voltage we have here. So if we name this VOC, voltage of the open circuit, and say basically this is O, this is C, because there is no load here, and even if there was a load attached here, you would have to take it out. That's part of the principle of this Thevenin theorem, that you have to take the load out, disconnect it, and then find out how much the voltage is here, and also how much the resistance is. So we've already found the internal resistance. Now we want to find the voltage of the open circuit here. Because there is no load connected here, so there is no current going through this resistor or this resistor. So R2 and R5 are basically redundant. So we can just ignore those, redraw the circuit as a battery here, 120 volts, these three resistors in series with it. And so we don't have these two resistors anymore. So you can say VOC equals VAB, I've named it here, AB. And how much is that? It is, if you use Ohm's law, this is only a series circuit, very simple. So if you find the current in this series circuit, which is constant, the current that goes through R1 is the same as going through R3 and R4. There is no current going the other way. It's open loop. So this current, if you find the current times this R3 will give you voltage of the AB, voltage drop, or voltage of the AB, which is in this case voltage of the open circuit. So VOC equals VAB, and that is I times R3. How much is I? Is 120 divided by the sum of all these three resistors, because they are in series. That is the total resistance. So the total resistance in this case is R1 plus R4 plus R3, or R1 plus R3 plus R4, and if you put the values there, that's 8,820 ohms. 120 divided by that, that is the formula, voltage divided by RT, that gives you current, 2 over 147 amps. If you just convert that, you can find the decimal value, and or you can just leave it as that. I would rather if you could just convert that to fractions, ratio in decimals, sorry. If you could just convert that to decimals and find the value, let's just see, 2 divided by 147, that's 0.0136, so which is 0.0136 amps. Then, because you have the current times R3, like I said, is your voltage. So you times that by 8,200, you'll find your voltage is 111.5646 volts. 2-3 decimals is enough. And the circuitry, draw the circuit, the Thevenin equivalent circuit will be the voltage of the equivalent circuit, VOC, is 111.5646 volts, and the RI, which we found, is 2076.417 ohms. Now, to have the maximum power transfer to the load, the condition is when RL equals RI, you have the maximum power transfer to it. So RL has to be exactly the same as RI. That's just the principle. And we've proven that in the class. But as long as you know RL equals RI, that'll give you the maximum power. So to find the maximum power, the formula for power is I squared times RL. So we have to find I to multiply that by RL, to square it and multiply it by RL. So I squared RL is your power. To find the maximum power, we need to find the current first then. And current is voltage divided by overall resistance, and these two resistors in series added together. So the formula is I equals VOC over RL plus RI, or RI plus RL. So I is VOC over RI plus RL, and if you put the values there and do the maths, I is 0.02686 amps in the Thevenin's equivalent circuit. Now don't get this confused. This is not the current that you found earlier. This current was for that circuit, for that purpose, and this current is for Thevenin's equivalent circuit. That is the current that goes through the load. That wasn't the current that was going through the load. That was different. So you found the current. You put the current in this formula, I squared times RL, and you have the RL. You find the power, and that is your maximum power, 1.498 watts. Now, in order to prove that this is the maximum power, and maximum power basically occurs, in order to prove that maximum power actually occurs at this value when RL equals RI, then I'll just take you to a spreadsheet, and instead of just showing you this way, I'm just going to delete all these and just do it from the beginning. So because you're just starting fresh, I'm just going to delete all these and just delete all that, delete the curve, delete the graph, just start from fresh. All I've done here, I've put down the voltage of the circuit that we've calculated, 111.56, whatever it was, and the resistance, internal resistance, 2076.417. It doesn't matter which column, which row you pick, you can just do that. You don't have to highlight them. I just highlighted them for myself, and I've highlighted this one as well, and I put a table here. Again, you don't have to, you just have to name the top of them. Just say RL, resistance to the load, in ohms, current of the load, IL, you could say, in amps, and power dissipated in the load, or you could say PL in watts. And go almost to the middle of, just give a few spaces, a few rows of space for lower and higher values, and then pick this middle one. Just basically what we're saying is at RL, when RL equals RI, the maximum power occurs. So I'm just going to put the same value as RI, 2076.417. And at this point, I want to formulate current. So for current, I just say IL equals. So you just click on this box, go on top here and say equals. What was the formula for that? The formula was, as you see, VOC over RI plus RL, or RL plus RI. So we need to write that. And for power, formula is I squared times RL. So we use these two to write our formula for current and power. For current, I equals VOC, which is this one, 111, and we found this, how much it was, 111.5646. We just go with 111.56. we just leave the rest of it 46. Because it's fixed value, I'm just going to actually type it as it is, so you don't need to go and click. You could go and click on this, but we're not going to do that. I'm not teaching you Excel or how to work with this spreadsheet. I'm just teaching you how to just do a quick graph for this particular example. So 111.56 divided by, parentheses open, RI is fixed 2076.417 plus RL. Now, because we're going to change that RL, I'm just going to click on this, which turns out in my case C8, because it's column C, row 8. In your case it might be different. It doesn't matter which column and which row you start typing, and as long as you get the correct results. And then close the bracket, and before moving your mouse anywhere else and clicking on anything else, as you're here, you just press enter. Now you've formulated that one. Once you've done that, just go to the corner, the right bottom corner of this box where your cursor shows as a cross, then drag it up, click on it and drag it up, and drag it down a few rows. Now it is formulated, and all the values at the moment, it just shows similar to each other, apart from this one. Because for this you haven't got values here. So what we need to do, we need to put values, because it's saying vary the value of the resistance of the load and find out the current and power to see and prove that maximum power occurs when RL and RI are equal. And you need to explain and write that in your assignment. So what we do, we just increase and reduce the values here. And just go down. The closer the values are, the more accurate your curve is. So you can do increments of 25, 250, or whatever, however you choose. So I'm just going to go next one, 2050 and 2000. 1575 and 1500, 1275 and 1200. So we just go various values and then go up 2100, 2100, 75, 2200, and so on, 2250. I'm just going to do a little bit of a jump, 2275. and you get the gist. So we've got all that, and we've got all the currents in amps, and we need to formulate the power. Power is I squared. This is I squared times RL. So we need to go into this box, click on here again, say equals. For I squared, I'll just open a bracket, no parentheses, and click on I, which is in this case here, and mine happens to be D8, column D, row 8. Again, yours will be probably different. And for power, to say squared, because it's I squared times RL. For squared, you press Shift 6 on your keyboard. It shows this upper arrow, up arrow, and press 2. That just means squared in a spreadsheet or Excel. And close the bracket and say times RL. Click on RL and then enter. And this is your power, 1.49 of 1.5 watts that we've calculated as well in our calculations. It was that much, 1.498 watts. So it is right. And then again, you drag this up and down. You click on the lower right button of this box and drag it up and drag it down. The beauty of this is you don't have to calculate for each current, each resistor to find the power and show that power, maximum power occurs at this point. And you can see maximum power if you compare these adjacent ones. You can see maximum power occurs at this point where RL equals RI. And to show that as a graph, you just highlight this column as RL and highlight this one, power, and go into insert on top and pick insert scatter or bubble chart and pick one of these graphs. Just pick that. Mine is a little bit jaggedy because of the values I picked. It was just a little bit random. If you go by equal increments and decrements, you'll see a nice curve there. So I would suggest that you do that in your assignment. Just make sure the number of increments that you have are all equal. If it's 25 each or 50, or just go equal values so you don't have a jaggedy curve like that. But however, it shows the maximum occurs around about this 2076, and to be accurate, that's your maximum power. That's power, and this is your resistance power. All right, I hope now you can manage doing the rest of your assignment and achieve your maximum potential, and ideally everybody get a distinction, really, because we've done everything in the class and I've got videos here. You should be able to do everything else and just copy and explain them and put your own values there. So that's the end of that. And so you can just put a screenshot of that in your Word document, or just send it separately. Email me. If you have any questions or any comments, let me know, and don't forget to subscribe and share and like. Goodbye and see you later. Bye-bye.